Here is one of the very important topic regarding to Maxwell's equations, that is word statements of Maxwell's equations. Very important topic, word statements of Maxwell's equations. That means in our previous sections we have already discussed regarding to the four Maxwell equations, and those are obtained from different laws. Those four Maxwell equations are del dot d bar equal to rho v, del cross e bar equal to minus dou b bar by dou t, del dot b bar equal to 0, and del cross h bar equal to j bar plus dou d bar by dou t. Those are the four Maxwell equations we have obtained from our previous discussions. Now we are representing those Maxwell equations in word statement form. That means we have already discussed the first equation is derived from Gauss law. The first equation is derived from Gauss law in our Maxwell's equations point of view. And look at here, the first equation. The Maxwell's first equation states that the total flux out from the closed loop is equal to the net charge within the surface. That means surface integral of d bar dot ds bar equal to q enclosed. Here d bar is the flux, d bar is the electric flux density. This over surface value will be gives us enclosed value. And the second Maxwell equation is this. It is the integral form. The second Maxwell's equation states that the surface integral of, here it is the surface integral, the surface integral of b bar, it is the b bar, that is magnetic flux density b bar over a closed surface is always equal to 0. That means surface integral of b bar dot ds bar is equal to 0. It is our Maxwell's second equation statement. And while coming to the third equation, third word statement is third equation. The third Maxwell's third equation states that the curl of electric field intensity, look at here, it is the del and it is electric field intensity, it is curl. The third equation states that the curl of, it is a cross product, curl means cross product of electric field intensity E bar is equal to the negative time rate of change of magnetic flux density. Here B bar is magnetic flux density, here is negative. Dou by dou t means rate of change of, so negative here rate of change dou by dou t of magnetic flux density, that is B bar. Next, Maxwell's fourth equation states that the closed line integral of magnetomotive force is equal to the sum of conduction current and displacement current density enclosed by the path. That means here we have already derived an expression in the topic of inconsistency of Ampere circuit law. So look at here, closed integral of magnetic force is equal to J bar, that means conduction current, and displacement current density, that is dou d bar by dou t. We have already derived expression for this. So these are the four final word statements of Maxwell's equations. Very important question.